So, hello everyone, welcome back to my YouTube channel Chembiosis. So, in this lecture, I am going to discuss about the concept of carbocation and carboanion, as well as I am going to discuss about what is called the electrophiles and what is the nucleophile. So, this is the second part of the acid-base reaction chapter. So, this is very important concept. Listen to this lecture carefully. So first of all, what is called the carbocation and what is called the carboanion? So you suppose that we have one compound that is called methane, CH4. So in methane compound, you can see that these bonds, that CH bonds, are basically the covalent bond, and each atoms are sharing one electron each to form this covalent bond. So after sharing these electrons, we have total 4 covalent bond. So the number of electrons that is contributing to the covalent bond is 4 into 2, that is equal to 8. So using these types of structure, the octet of the carbon atom has been fulfilled. So that's why this carbon atom that is present in methane molecule is neutral one. But what happened if this hydrogen atom take this bonding pair electron? It can be hydrogen atom or any other groups. So what happened if these 2 bonding electrons are taken by this group? In that case, you can see there will be only 3 covalent bond that will be present, and each covalent bond will share 2 electrons. So in that case, carbon has total 6 valence shell electrons. So its octet is now not fulfilled. So because of that reason, after this bond breakage, what happened that this carbon atom will have a positive center. So this positive center carbon is called the carbocation. So you can see carbo is because it is the positive center is made of carbon, and as it is forming a cation, so it is called the carbocation. Now what happened in case of carboanion? So in that case of carboanion, instead of this bonding pair, this group taking out the bonding pair, it will leave this bonding pair electrons to the carbon atom. So this Z group or any other group will give away these 2 bonding pair electrons to this carbon atom, and now this carbon atom has excess electron. So due to that excess electron, it is previously these 2 electrons are shared between carbon atom and that Z group, but now those 2 electrons are wholly centered on the carbon atom. So because of that reason, now the carbon atom has an excess negative charge. So that's why it is called carboanion. So carbo means the center is made of carbon, and because of that negative charge, it is called carboanion. So these carbocations or carboanions, these are very less stable and they are very reactive. So their stability is very less, so they always combines with other groups and try to form a stable compound. So that's why they are very reactive, but they are generally produced in a reaction intermediate. So that's why they are very less stable. Now coming back to the concept of electrophiles and nucleophiles. So what is called electrophiles? So electrophiles, it composed of 2 words, that is electro and another is philes. So electrophiles means electron loving. So the group that is electrophiles, or the center that is electrophiles, loves the electrons. So as we have said in my previous slide, that in case of carbocation, this carbon atom is having a positive charge on it. So due to that positive charge, it always try to get neutralized. So it has a very huge tendency to attract electrons from others. So if there is any base that is present near the vicinity of this electrophiles or the carbocation, this base donates its 2 electrons to this carbocation and it will form these types of bond. So by forming these types of bond, now the octet of the carbon has been filled up. So that's why these types of electrophiles are very reactive. Now these electrophiles are also called a type of Lewis acid. Why we are calling these electrophiles as Lewis acid? This is because I have discussed it in my previous talk that all Lewis acid has the tendency to accept electrons from others. So as you can see, this carbocation or this electrophiles has the tendency to accept the electron from any base. So that's why they are called the Lewis acid. So there is another example of electrophiles, that is this carbonyl center. So you can see that there is a carbon atom and it is doubly bonded with the oxygen atom. So due to the difference in the electronegativity between carbon and oxygen, this carbon atom has partial positive charge and this oxygen atom has a partial negative charge. So due to this reason, this carbon center is partially positive charge and it has a tendency to draw electrons from other. So if there is any base that is present near the vicinity of this electrophiles or this carbonyl group, the base will give 1 electrons to it and it will form this types of compound. So that's why this center is also called the electrophilic center, because this carbon center wants to take or the draw electrons from other bases. Now this is the electrophiles. Now coming back to the nucleophile. So a nucleophile always seeks for positive center, especially the carbon atom. So I have told you that all Lewis base has a tendency to give away the electrons. So that's why all Lewis base are nucleophiles, because they always want to give away 2 electrons to any carbon center or electrophilic center. So you can see this is a nucleophile which is having an excess negative charge or an excess electrons on it. So it will try to give away to any electrophile, that is the carbonyl group here in this case, and it will form a neutral group or neutral compound, and these types of compound will be formed. So this is called the nucleophile. So overall we can say that all carbocations are basically electrophiles because they love electron, they want to get electrons to fulfill the octet, and all carboanions are nucleophile because as they wants to give away its excess electrons to any electrophile, and also it will get stabilized. So that's it from this chapter. In the next talk I am going to talk about the acid strength, how we could measure the acid strength of any acid or basic strength of any base. So till now, bye bye, and we'll see you in the next lecture. Thank you.